Everyone done with this? You just need to calculate the value of n factor or valence factor. You know how to calculate molar mass, right? So equivalent mass has a formula, or equivalent weight has a formula, that is molar mass upon x, that is also called n factor or valence factor. So you can easily calculate the molar mass, right? Anushka, Sakina, and Alan, what is the value of x here for A? Value of x is equal to 2 because it will give you 2h plus. What is the value of x for B? Sakina and Anushka?
Sir, 3.
3. That's good. What is the value of x for C? Sakina?
Sir, 3.
3. Anushka, what about you? Anushka, are you there? So the value of x here will be equal to 2. I will explain why it is so. And here the value of x is equal to 1. Now this is quite easy. H2SO4. If you are going to dissociate into ions, it is an acid. So it will give you 2H plus SO4 minus 2. That's why the value of x here will be 2. And if you are going for H3PO4, it will give you 3H plus PO4 minus 3. Why it gives you 3H plus and this gives you 2H plus? So we can explain with the help of the structure of this. So you can see in H3PO4, we have this structure in which you have 3 OH and the electronegativity difference between O and H is quite high, and this becomes negative and positive, and this bond will be easily broken. That means it will give 3H plus. That's why the value of x here will be 3. When we are going to talk about H3PO3, you can see it will give you only 2H plus, and here it will be HPO3 minus 2. Why it is so? We can explain with the help of the structure of this. So you can see this is the structure of H3PO3. Now we have two OH bond. So this is negative, basically this is positive. This will be dissociated and it will give you only 2H plus. That's why X here will be 2. The electronegativity difference between phosphorus and hydrogen is not that much. The bond is not that much polar. That's why this hydrogen will not be dissociated. And for D, we have H3PO2, which will give you only one H plus. Only one H plus. It will be like this. We can also explain with the help of the structure of this. It has only one OH bond, which is polar. So there will be delta negative and delta positive, and this can be dissociated. So X here will be equal to 1. Is that clear?
Yes, sir.
Please do write it. Please do write it and then let me know. Are you done with this?
Sir, almost done.
Okay.
Yes, sir, done.
Very good. Now for Na2CO3 and CaCO3, since it is a salt, so we can also do this. When you are going to dissociate it, it will be dissociated into Na plus and CO3 minus. To balance it, you have to multiply it by 2. X is equal to either negative charge or you can take total positive charge. So it will be equal to 1. Is that clear? Anushka?
Yes, sir, clear.
So this is how we are going to calculate all this. CaCO3 that will be equal to Ca plus 3 plus CO3 minus 3, and here X will be equal to 2. Can I turn off my video because it's not working? I'm trying since it's starting. Anushka, Sakina, okay, Sakina. So please do let me know so that we can move to the next part of the normality, which is number of gram equivalent. Number of gram equivalent. Number of gram equivalent has a formula that is given mass upon equivalent mass. Given mass upon equivalent mass. So you have to be careful when you are going to calculate the number of gram equivalent because you need to calculate separately equivalent mass of the compound and then put the value here. Okay, because we already know that equivalent mass has a formula that is equal to molar mass upon X. Is that clear? Anushka, Sakina, are you there?
Yes, sir.
Please do let me know so that I can change the slide.
Yes, sir. Done.
Okay, I'm going to give you a question on this formula. 4.9 gram of H2SO4 presenting 500 centimeter cube of solution. Calculate. Actually, we don't need it, but I'm going to calculate number of gram equivalent. Number of gram equivalent. Please do.
Sir, 0.1.
Let me just check it. If you are going for number of gram equivalent, you know the formula. This is equal to given mass, which is 4.9 gram upon equivalent mass. So we can easily calculate the equivalent mass of what? H2SO4. So it is molar mass upon X, and you know the molar mass of H2SO4 is 98 and X is 2. So here you can get very good. You put 49, and after removing the decimal, you will get 10 here, and it will be cancelled. 1 by 10, that means 0.1 gram equivalent. Is that clear how we calculated number of gram equivalent?
Yes, sir.
Okay. Now moving to the main concentration term, that is your normality. Now I'm going to define this normality. Then we will move to the next step. So normality is number of gram equivalent of solid. Gram equivalent of solute per unit volume of solution. Per unit volume of solution in liter. That means basically, if you have this normality, we can write mathematical equation from this sentence. Normality is equal to number of gram equivalent upon volume of solution in liter. Volume of solution in liter. So this is the formula from where we can calculate normality. you have to calculate separately the number of gram equivalent, then put the value here. And I also give you the formula for number of gram equivalent. You know that number of gram equivalent is equal to given mass upon given mass upon equivalent mass. So only a step increases, but the concept is similar, and equivalent mass is equal to molar mass upon X. Is that clear? So now I'm going to give you a very simple question. The same question basically. 4.9 gram of H2SO4 present in 500 centimeter cube of solution. Calculate normality. Please do. And let me know the answer.
Sir, 0.3.
0.6. Is there any answer from Regina? If you're going to calculate normality, you know the formula. Number of gram equivalent upon volume of solution in liter. So first of all, we need to calculate number of gram equivalent and number of gram equivalent has a formula given mass, which is 4.9. And you have calculated the equivalent mass of uh, equivalent mass of H2SO4, which is 49. If you are going to remove this decimal, there will be 10 and this will be cancelled, and then you will get 0.1 gram equivalent. Is that clear? This is your number of gram equivalent. Volume is also given as 500 centimeter cube, which you can easily convert in liter, and it will be divided by 1000. Now it is in liter, that is 0.5 liter, right? So now you just need to put the value 0.1 upon 0.5. So you will get 1 by 5, right? You will get 1 by 5. This is either you can write gram equivalent per liter, or either you can write 1 by 5n. You can also write it in decimal form 0.2n. Where you have mistaken.
Sir, I by mistake told 0.3. I got 0.2 only.
Oh, can I change the slide?
Yes, sir.
Now see, calculate normality of fall. 10% weight by volume, CaCO3. 20% weight by volume, NaOH. 6.3% weight by volume, HNO3. I think you can do it. If you will you have any doubts, please ask.
Sir, can you solve the first one and show how to do it?
Now, what you just said, Sakina?
Sir, can you solve the first one and show how to do it?
Sakina, do you know how to extend this in a sentence?
Yes, sir.
So if you are going to do it, if you are going to write a sentence about it, you will get it. Just try, give it a try, and if again you will not get it, then I will explain it.
Okay, sir.
Do it step by step, the way we did for in molarity. You have seen the similar question, right? In terms of weight by volume percent, right?
Yes, sir.
In the same way, you need to do whenever a question in this form, weight by volume, weight by weight, weight by volume is given, you need to write a whole sentence about it, and then write the formula of the question, whatever is asked, and then do it a step by step. Please do it. Sakina, are you able to solve it? Yes or no? Alan?
Yes, sir.
Okay, please do it. Everyone done with this? Yes or no?
The first for 1.2 and
Hmm. First one you are done with.
yes,
Sakina,
sir.
what about you? Thank you, Alan. Sakina, what about you? Are you able to solve it or not?
Sir, I'm still doing.
Okay. Just let me know when you are finished with the first.
Sir, could you explain this question?
Okay, Sakina, how much you have solved?
Sir,
Hmm.
Sir, I solved till the weight by volume.
So it's given that, very good, 10% weight by volume. CaCO3 is given, right? This is the question, and we need to calculate normality. So what I told you, to expand this in a full sentence, and from where we will get everything. That means 10 gram of CaCO3 presenting 100 ml of solution. 100 ml of solution. So as you can see that this 10 gram of CaCO3 is your given mass, and also this 100 ml of solution is your volume of solution. Now it's very easy. Apply the formula of normality. Normality has a formula which is number of gram equivalent of solute upon volume of solution in liter. Volume of solution in liter. Now, as you can see, volume is given. Only we need to calculate it, convert it into liter. What we need to work on is number of gram equivalent. Number of gram equivalent has a formula that is given mass upon equivalent mass. Given mass upon equivalent mass. Now, as you can see, given mass is given, that is 10, but equivalent mass we need to calculate, and equivalent mass has a formula that is molar mass upon X. X is n factor. Molar mass of what? We need to calculate the equivalent mass of CaCO3. So, molar mass of CaCO3 is 100 gram, and since it is a salt and we has plus 2 or minus 2, we can take either of them. So, 2 is the valence factor. We will get the equivalent mass as 50. Now we need to put the value of equivalent mass, then we will get 1 by 5 gram equivalent. This is the number of gram. And also volume is 100 ml, which can be easily converted into liter by dividing it by 1000, and we will get 1 by 10 liter. Now you can easily put the value here. Number of gram equivalent is 1 by 5. Volume of solution in liter is 1 by 10. This is your gram equivalent, and this is your liter. Now you can easily calculate it. 1 by 5 into 10 by 1. That means basically you will be getting 2 gram equivalent per liter, or either you can directly write 2n. Isn't it easy? Anushka?
Yes, sir.
Yes, sir.
It's so easy. You just need to do it stepwise, and you will get it. Sakina,
Yes, sir.
please do write it and do the two more question I had given you. Let me know if you have any doubt. Are you done with this, uh, Alan?
Yes, sir.
Now, what is the answer for the B and C?
B I got as 3 and C I'm still doing it.
And C for C?
No, I'm still doing it.
Okay. Okay.
Can you just scroll up the question?
What you just said?
No, can you scroll up to the question? I can't see the C part.
Okay. What about Sakina and Anushka?
So SB 6.25.
What you just said?
Option B is 6.25 and option C is 0.1.
6.25.
Yes, sir.
It's for the third one, right?
Oh, yes, sir. Then the other one is 0.1.
Okay. Wait a minute. I'll just check it. Anushka, what is the answer for the second one? 20% NaOH I had given, weight by volume NaOH. What you need to do? Just extract a sentence from here and you will be getting 20 gram of solute, that means NaOH, present in 100 ml of solute, 100 ml of solution. Now what you need to do? Calculate the normality, which has a formula. Number of gram equivalent of solute, that means NaOH is the solute, upon volume of solution in liter. Now you can see volume is given 100 ml, so it can be easily converted into liter. What we need to do is to calculate number of gram equivalent. number of gram equivalent as a formula, which is given mass that is already given 20 gram upon equivalent mass. So equivalent mass, you can easily calculate equivalent mass of NaOH, which is a formula molar mass upon X. Molar mass of NaOH is 40, and since it is a base, it will give only one OH minus. So the value of X here, the value of X, wait a minute. So the value of X here will be 1. So the value of equivalent mass will be equal to 40, and we will get 1 by 2 gram equivalent. Now what we need to do, put the value only and you will get your answer. So now you can say it will be 1 by 2 into 10. That will be equal to 5. This is what you get, what you have got, Alvin.
Yes, sir.
Very good. Anushka, are you there? For the third one, I'm going for the third one, which is 6.3% weight by volume. 6.3% weight by volume, HNO3. Again, what you need to do, 6.3 gram of HNO3 present in 100 ml of solute. 100 ml of solute. Now going to calculate the value, number of gram equivalent upon volume of solution in liter. Again, you can see number of gram equivalent has a value given mass that is given 6.3 upon equivalent mass. So equivalent mass can be easily calculated. Molar mass of HNO3 63 upon X is 1. So this is the number of gram equivalent. If you are going to calculate it, you will be getting 1 by 10 gram equivalent. So this is your 1 by 10 gram equivalent and 100 ml solution. So we can easily convert it into liter. So as you can see, this is what you will get, 1 by 10 upon 1 by 10, which will be cancelled with each other, and you will get 1. This is what you have got.
Yes, sir.
Okay.
Done, sir.
Done, everyone?
Yes, sir.
Okay. Now moving to the main on the main topic of this chapter. Before that, I just want to give you one last question on this. Calculate mass of NaOH. If volume of solution is 250 ml. If volume, wait a minute, if volume is 250 ml of a bi-normal solid, it's a very important And is the question. Are you done with this? Anushka, Alan, Alan, what about you?
I'm still doing it, sir.
Normality is given. I'm going to give you the hint. By normal, that means normality is given, and normality is 2 and best. Your normality is 2. So first you are going to calculate number of gram equivalent. You need to calculate this part. Then you will get your answer easily. Sakina, are you able to solve it? Yes or no?
Sir, I'm still doing it.
Okay. Please,
That's a 0.1 gram.
0.1 gram, I think. I'll check it. Maybe it's wrong. I think 5 gram will be the answer, perhaps. What is the number of gram equivalent that you have got?
So the number of gram I got.
Okay, see, I'm gonna give you in this. Normality has a formula, number of gram equivalent upon volume of solution in liter. Now, as you can see, normality is 2 given, number of gram equivalent as it is, I'm gonna write upon volume of solution is 250 upon 1000. If you are going to calculate this, this will be 1 by 4, and this 4 will go in numerator. So number of gram equivalent will be equal to 2 upon 4. That means 1 by 2 gram equivalent. This is what you will get. This will go in numerator and it will be in multiplication. So number of gram equivalent will be 1 by 2 gram equivalent. Yes or no? Please do let me know.
Yes,
You
sir.
got it? Now see, we are going to apply this formula separately. Number of gram equivalent as a formula, that is given mass that we need to calculate upon equivalent mass. Equivalent mass of what? Oh, wait a minute. Yes, NaOH is given. So you can easily calculate the equivalent mass of NaOH, that is molar mass upon X, and molar mass of NaOH is 40, and the valence factor is 1. So you can see M upon 40 it will be. And here it is. What is the gram equivalent? 1 by 2. 1 by 2 it is. So mass is 20 gram. Mass is 20 gram, not 5 gram. Mass is 20. This is how what you will do. Is that clear?
Yes, sir.
Can I move to the next part?
Yes, sir.
Okay. Now, Sakina and Anushka, are you done with this?
Yes, sir.
Okay.
Yes, sir.
Okay. Now I'm going to start the new topic, that is solubility. What is solubility? So basically, amount of solute dissolvable or soluble in a fixed amount of solvent, that is called solubility. So I'm gonna define it right with me. The maximum amount of solute dissolved in a specified amount of solvent at constant temperature. At constant constant temperature is called solubility. Basically, there is a solubility principle which solute will be dissolvable or soluble in which solvent. So there is a solubility principle, and it says that like dissolves like. Like dissolves like, that means basically if a polar solute you are going to dissolve it in a polar solvent, then it will be dissolvable. That means basically polar solute will be dissolvable or soluble in polar solvent, and non-polar solute will be dissolvable in non-polar solvent. Is that clear? Now, factors on which solubility depends. Factors on which solubility depends. So the first one is nature of solute and solvent. Nature of solute and solvent. The second one is temperature, and the third one is trace. First, do write it, then let me know. Then I will show you how do they depend on just different quantity. Are you done with this?
Yes, sir.
Very good. So let's just start how do they depend on nature of solute and solvent. As I already told you, they follow a principle that is like dissolves like. That means polar solutes are soluble in polar solvent. Like if you are going to take polar solvent, that is H2O, and polar solute, that is your NH2. And in the same way, non-polar solutes are soluble in non-polar solvent. Non-polar solvent. For example, non-polar solute, you can take CCl4, and non-polar solvent, you can take then CCl. So this is also the criteria or principle of solubility that like dissolves like. Please do write it. Are you done with this? Very good. Now see about the effect of temperature. So write this topic, effect of temperature. Now if you are going to dissolve a solute in a solvent, you have to see whether the process is exothermic or endothermic, and accordingly, I will tell you what will be the effect. So the first is if dissolution, that means you are going to dissolve solute into solvent, process is exothermic. Anushka, what does exothermic process means or exothermic reaction? Then
In exothermic reaction, heat is released, while in
heat
endothermic,
is released.
it
That
is
means in
absorbed.
very good, very good. That means Anushka, the reaction or the process has already heat energy a lot. That's why it releases. And if you are having, if you are going to dissolve a solute in a solvent, which is an exothermic process, and in this exothermic process, if you are going to increase the temperature, which is not in favor of dissolution, that's why the solubility decreases. Are you getting my point? It's very simple. It is an exothermic process. It will release heat. It will release heat to stabilize itself, and at that time you are going to increase temperature. That means you are indirectly giving heat energy to the system, which is not in favor of that process. That's why solubility decreases here when you are going to increase the temperature if it is a exothermic process. And if dissolution process is endothermic. Endothermic is a process which requires heat energy, right? Then with rise in temperature or with increase in temperature, solubility increases because it requires heat energy, and at that time you increases temperature. That means indirectly you give heat energy. That's why with rise in temperature or increase in temperature, solubility increases and vice versa. Solubility increases. So please do write this. Let me know when you are done with.
We're done.
This is it for today. I'll see you in the next